Welcome, pre-algebra students. We're in lesson 1. We are going to start with a little bit of a brief review. Let's begin with the number system itself. So we know that we have 10 symbols to represent all of the numbers that we use. And we have those 10 symbols because we have 10 fingers. So people began counting on their fingers. They had 10 of them, and that laid the foundation for our base 10 number system. And the entire world uses it because, for the most part, the entire world has always had 10 fingers. So, those symbols, of course, that we use are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we understand something called place value when it's applied to these symbols, that the place of a number or a place of a digit in a number represents its value. So for instance, if I wrote the number 642 or 642, we know that this is a hundreds place, this is a tens place, and this is a ones place. And we can write that value in something called expanded notation by multiplying that number by the place that it represents. So what that means is I would write 6 times 100 because 6 is in the 100s place, and I would add that to 4 times 10 because 4 is in the tens place, and I would add that to 2 times 1 because the 2 is in the ones place. And that would give me 600 plus 40 plus 2, which equals 642. And that's how we understand the value of the numbers that we work with. Where it's located gives us the value. Let's say we have a larger number. I'm going to write this down here. As we get to larger and larger numbers, sometimes our digits are repeated. So for instance, I have a 2 here and a 2 here and a 1 here and a 1 here. And we understand that this 1 is greater than this 1 because it is further to the left of the decimal point. The decimal point is like our point of origin. And the further to the left, the bigger the number, because we add the zeros behind it that increases the place value, right? Just like we did here, we had 2 zeros behind the 100 and 1 zero behind the 10 and no zeros behind the 1. It increases the value. Now, one of the things that we do to help us recognize that value and kind of keep it straight when we look at it is we use commas. And what we do is we count 1, 2, 3 and put a comma, 1, 2, 3 and put a comma. And that just helps us to group them into repetitive groups that illustrate value better for us. So we recognize this as being our hundreds place, right? Or our ones group. This is where everything begins. So this would be our ones, this would be our tens, and this would be our hundreds. And we consider this our ones grouping right here. Here we have thousands. That's our next grouping up. And again, we have a ones place, a tens place, and a hundreds place. And then the next group is what we call millions. And it has a ones place, a tens place, and a hundreds place. And you can see the pattern repeating. Ones, tens, hundreds, ones, tens, hundreds, ones, tens, hundreds. And all that means, it's just a way for us to understand where it's located within the group. Every group after this, as the number gets bigger and bigger, repeats. It has 3 digits in each group, and each group is ones, tens, hundreds as it goes from right to left. Right? So this would be 147 million, and wherever the comma is, that's where we say the name of the group. 625,000, because that's where the comma is, 321. And we don't say ones after the end. That's the only thing that we don't do, is we just, when we get to the last number, we drop that, right? It's just whatever this number is here, because this is actually the name of those singles that we had originally. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that's how we would say that. And that's also the way that we say it is exactly the way that we would write it. So let me show you here below what that looks like. So here I've written it out for us. And again, just like I said a moment ago, 147 million, wherever the comma is, that's where you say million. And when you write it, that's also where you write a comma too. So if there's a comma here, you say the group where the comma is, and then you put a comma behind that. And another thing, when you're writing these combination numbers, the 10s and the 1s together, we put a hyphen between them. Any number between 20 and 100, we put a hyphen between it, unless it is 20 or 30 or 40 or 50. If it's not got a 0, if it has any number but 0 in the ones place behind here, then you use a hyphen to combine those into one value. So 147,625,321. That is how you would say it. That is how you would write it. It is exactly the same way. Notice whenever I say each group, I put it in that original hundreds, tens, ones format, 147, and then I just mention what group it's in. That's all you're doing. 625, and then, oh yeah, that's the thousands group. 321, yep, that's the last group. I don't have to say anything else. So that's how you would write it with the commas. That's the pattern that we're seeing here, ones, tens, hundreds in every group. And then this is the way you would write it out in longhand. And knowing how to write it out in longhand is going to help you whenever you get older and need to write checks. We have to write checks out in longhand on the second line of a check. So understanding where it is has a specific value. That's our expanded notation. That's how we write that to show that value. And then understanding where to put the commas shows that we understand the place and the pattern of those place values. And then understanding how to say it also further illustrates the values of the numbers and the groups and the patterns that they are in. So all of this is important. You're going to want to write all of this down in your notes. I'm sure you all have your spiral notebooks beginning pre-algebra lesson 1. And you're going to want to write down any formulas that you have on the back cover. We don't have any formulas yet, but when we get to one, I will remind you to write that on the back cover of your notebook. All right, so moving on, we've talked about place value, expanded notation, reading and writing the whole numbers. So let's talk a little bit about adding them together and how that works. We know when we add, the place value changes, or the digit changes in each position. I'm going to clear the page so we can begin. If you ever, as we go through the course, if I ever go too fast and you haven't written everything down, pause the video, finish writing, and then press play. You have control over how fast this is. You can slow down the video. You can speed up the video through your settings. So take advantage of that, but you can also pause. You can rewind. All of those things are going to be beneficial for you to understand that you can do, so you don't finish a lesson and go, what did I just watch? All right? Pause me if I'm going too fast. I expect that. You can do this. Just, sometimes we need a break from Miss Tracy so we can finish writing everything because she talks a little too fast sometimes. That's okay. All right, let me clear the page. And we are going to talk about adding these numbers. So I am going to give you example problem 1.6. And let's see a list of numbers here that we need to add. And if you notice, each one of these has a different quantity of digits. So there's, as these go to the left, they're bigger and bigger numbers. We're going to add these together. So let's do that now. We know that 4 and 7 is 11, and 11 and 6 is 17. So we write a 7. What do we do with that 1? We carry it. So we bring it up to the top to carry, because that's a whole set of 10 that we need to move over to this other place value, because the 10s belong in the tens column. All right, 1, 0, and 2 equals 3. So these numbers added together gives us 37. Now 4 and 5 equals 9. And then we bring down the 3 because there's nothing to add to it. So these numbers added together gives us 3,937. And that's how we would say that. Don't forget to put your comma in. Your comma is important. You're going to need to do that whenever you type your answers into the system. Many times it might say that it's the wrong answer because there's no comma. The comma talks about and tells us and communicates the place value for those numbers. So be sure to put your comma in. So what about with money? We know that money deals with decimals. So let's look at how that would work. This is example 1.7. We have $2.54. And notice when I bridged the gap from the whole numbers to the change, I said and. And in mathematics just means plus. That's all it means. It means to add. And many times when we're talking with money, we want to keep dollars and cents together. So we want to combine them. So we say and for the decimal when we're talking with money. And is not the definition. The decimal is not the definition of and. And means to combine or to add. That is all it means in math. And when we use it with money, we use it to indicate the fact that we are grouping whole dollars and part of another one together. That's all that means, right? Some professors or instructors will also use that with numbers that are not money, and that's okay because it still means that you're combining the two things together. Some people will use point, and that's okay too. It is just about understanding that you have whole numbers put together with partial numbers, right? Or a partial value of 1. So we have $5 and then we have 9 cents. And when we add 9 cents, we have to write it the same as all the rest of these. Even though this is only 9 cents, we need to put everything into a similar format so that we can understand what we have. If I were to write $2.54, $5 and like that, and then 9 cents like that, I could add that together because I'm kind of subconsciously understanding where the decimal point is, but it wouldn't make any sense if I were to write it like this. If I were to say, oh, $2.54, $5.09. I couldn't add that together because it's not relative. You have to make numbers relative or along the same format in order to be able to add them accurately. If I added them just like this, then that would be 18, and then that would be 6, and it'd be $2.68. Well, we've got $5 here. That can't be $2.68. That's wrong. So we have to put that in decimal format to be able to have a relative function or a relative format that makes all the numbers line up in place value. 4 and 9, that would be 13. Carry the 1, that would be 6. And then 2 and 5 is 7. So that would be $7.63. And that is the right value for this addition problem. All right, so this book that we're using, it's the Saxon Pre-Algebra 3rd edition. It's designed to permit you to automate certain upper level skills of arithmetic while the concepts of algebra are being introduced. The addition, subtraction, multiplication, and division are designed to provide paper and pencil practice. So you do not need to use a calculator for most of this. So wait to use the calculator until it gets harder. Right now, this should be mostly review for you. All of you should know how to add and subtract and understand place value and do the mathematics that we have to do without resorting to a calculator just yet. Let's wait and use the calculator for the hard stuff, okay? Because the more you're able to do in your head or on, pencil and paper and do the calculations in your head, the better or the more able you will be when the hard stuff comes around to translate it. All right, push your brain a little bit now and it will reap dividends in the future. Okay, don't get lazy on me is what I'm trying to say. Don't use that calculator just yet. I'll tell you when it's okay. That's all we have for lesson 1. That was pretty straightforward, I think. So I will see you guys in lesson 2. You have some practice problems after this to do to just kind of refresh your skills from last year, kind of get you in, kind of warmed up and ready for the rest of the school year. So knock those out, get your math juices flowing, and I'll see you in lesson 2.